Good morning students, I am Mrs. Gauri from Maths department. Random variable. Let E be an experiment and S a sample space associated with the experiment. That is, sample space for this event is S equal to small s1, s2, s3 and so on. Next one, a function, that is a function from to each element small s, from this small s to a real number is called a random variable. Random variable means a function defined from s to r is called as random variable. Consider the experiment. For example, consider the experiment of tossing a coin twice. Sample space for tossing a coin twice is head, tail, head, comma, tail. Now I define a random variable, that is the number of heads obtained in the two tosses. For this experiment, the sample space contain head and head, tail and tail. Number of head for this event is 2. For this one is 1. For this one is 1. For this one is 0. So the possible outcome for this event is 2, 0, 1, 0. That is x of s1 equal to 2, that means 2 heads. X of s2 equal to 1, that means 1 head. X of s3 is 1, that is 1 head. And then s of s4 equal to 0, that means there is no head. And then next, range space of the set. Range space. The set of all possible values of x is called the range space. For this example, the set of all possible values is 2, 1, 0. So range space of this example is 2, 1, 0. This is a graphical representation for random variable. And then types of random variable. There are two types of random variable. First type is discrete random variable and the second one is continuous random variable. For discrete random variable, a random variable is said to be discrete if it assumes only a finitely countable value or countably infinite value of x. A random variable is said to be discrete random variable if x assumes only finite or countably infinite number of values in the range space. That type of random variable is called as discrete random variable. Example for this discrete random variable is, let x be the random variable repeating the outcomes of 6-side die. Probability function. Let x be a random variable. Let x1, x2, x3, etc. possible values of a discrete random variable. Discrete random variable means range set of the random variable is finite or countably infinite values. Discrete random variable x. Then p of x. P of x means probability of x is called the probability function of a discrete random variable x. Then p of x satisfy this following two conditions. First one is p of x value greater than or equal to 0. That means p of x value always positive value. Always positive, and also summation of p of xi is 1. This means probability of p1 of x plus p2 of x plus etc. pn of x value, xn value is 1. Summation of probability of xi value always 1. If a random variable is, if a function p of xi is called as probability function, then that function is satisfied these two conditions. Next one is distribution. In statistics, distribution means the value of a random variable or data or spread or arranged. In statistics, distribution means the value of the random variable or set spread or arranged in this space. Discrete, and there are two types of distributions. First one is discrete distribution. In discrete distribution, there are three types. First one is Bernoulli's distribution. Second one is binomial distribution, and third one is Poisson distribution. Next, Bernoulli's distribution. P minus 1 minus P whole power 1 minus X is called as Bernoulli's distribution. 1 minus P whole power 1 minus X is called as Bernoulli's distribution. Here we have this distribution satisfies one condition, that is P plus Q value is 1. From this 1 minus P equal to Q, and then substituting 1 minus P by Q, it gives here Bernoulli distribution is of the form P of X equal to P power X into Q power 1 minus X. Here X value is 0, 1, 2, 3, etc. Next, example for Bernoulli's distribution. Tossing a coin and then football matches and rolling a dice are some examples for Bernoulli's distribution. Next one, properties for Bernoulli's distribution. Properties for Bernoulli's distribution. Expectation of X or mean value of X is P for Bernoulli's distribution, and the variance of the Bernoulli's distribution is PQ, and standard deviation for this Bernoulli's distribution is root PQ. And then in Bernoulli's distribution, success and failure probability denoted by P and Q. In Bernoulli's distribution, success and failure probability is denoted by P and Q such that P plus Q equal to 1. P and Q are constant for each trial. In Bernoulli's distribution, P and Q are constant terms. Each trial is independent of the others. The number of trials is finitely namely n. Next one is binomial distribution. In the binomial distribution, probability function is defined as P of X equal to NCX Q power n minus x into P power x, that is P of X equal to NCX Q power n minus x into P power x. Here this distribution satisfies one more condition, P plus Q equal to 1. From this we can find Q equal to 1 minus P equal to 1 minus Q or Q equal to 1 minus P. And then properties for binomial distribution. In binomial distribution, mean value is NP and variance is NPQ, and standard deviation is square root of NPQ. One more distribution in the discrete random variable is Poisson distribution. In Poisson distribution, probability function is defined as P of X equal to P of X equal to e power minus lambda into lambda power x divided by x factorial. Poisson distribution is also a discrete random variable distribution. The probability function of this Poisson distribution is called as P power minus lambda into lambda power x divided by x factorial. Next one, properties for the Poisson distribution. Mean, variance of the Poisson distributions are same. Here, mean of the Poisson distribution is lambda and variance of the Poisson distribution also lambda. Standard deviation of the Poisson distribution is square root of lambda. For Poisson distribution, mean and variance values are same. And then some properties for Poisson distribution. distribution. First one is the events are independent. And second one, average number of success in the given period of time alone can occur. No two events can occur at the same times. No two events can occur at the same times. Second one. Third one, the Poisson distribution is limited when the number of trials n is independently. And the mean and variance of the Poisson distribution is lambda, and then nb is lambda is finite where n is a constant. Next one, continuous random variable. A continuous random variable x is said to be continuous random variable. It can take all the possible values between the certain limit. A random variable x takes the range from a finite range from the limit value between any two limit value. That type of random variable is called as continuous random variable. That type of random variable is satisfy the following two conditions. Before that, example for the continuous random variable is the amount of rainfall for a rainy day and the height of the student in the class. Let small f. A function small f is said to be the probability density function. Probability density function, it is also called as PDF. A function small f is said to be the probability density function. Then the function f of x it satisfies the following two conditions. First one is f of x greater than or equal to 0. F of x always greater than or equal to 0. Second condition is integral minus infinity to plus infinity f of x dx value equal to 1. Which function satisfies these two conditions? That function is called as probability density function. This is the graphical representation for probability density function, and also this is the accepted range for this probability density function. Next one, for continuous random variable, we have two distributions. First one is normal distribution, second one is exponential distribution. For continuous random variable, domain of the distribution is minus infinity to infinity. Domain of the distribution is minus infinity to infinity, and range set of the distribution is 0 to 1. Now we can write the function for this. From continuous distribution, domain set is minus infinity to infinity from this, and then codomain is 0, 1. Normal distribution, the probability density function, that means this f of x satisfies the two conditions. First one, f of x greater than or equal to 0, and second one, integral minus infinity to plus infinity f of x dx value equal to 1. That type of function is called as probability density function, that is PDF. The probability density function of a normal distribution is defined as 1 by sigma root 2 pi into e power minus 1 by 2 into x minus mu divided by sigma whole square. That is 1 by sigma root 2 pi e power minus 1 by 2 into x minus mu divided by sigma whole square. And the mean of the normal distribution is mu, and the standard deviation also mu. And then standard normal variable is defined as z equal to x minus mu divided by sigma. Here mu is a mean value and sigma is a standard deviation of this distribution, and the distribution function is defined as f of x equal to 1 by sigma root 2 pi e power minus 1 by 2 into x minus mu divided by sigma whole square. And then variance of the normal distribution is sigma square. For this normal distribution, It's a graphical representation like a bell-shaped curve, and also mean, median, mode are same, that value is mean. In normal distribution, mean, median, mode, and these three values lies in the same line, that value is mu, and then area of the normal distribution is 1. So each side has an area 0.5, and also this side has an area 0.5. Next one. The total area of the normal curve is 1. Total area of the normal curve is 1. The area of the either side is 0.5 because the median cut the distribution symmetrically. That is, the normal distribution curve is symmetrical about y-axis. And then the normal distribution curve approach the x-axis asymmetrically curve either side of the origin. Exponential distribution. Exponential distribution also here continuous random variable distribution. Therefore, the f of x function is probability density function. It satisfies the two conditions. And then probability density function of the exponential distribution is a alpha into e power minus alpha x comma x greater than or equal to 0. And then variance mean value of this exponential distribution is 1 by alpha, and variance of this exponential distribution is formula for variance is expectation of x square minus expectation of x whole square, that is equal to 2 minus 1 divided by alpha. Thank you.